Thank you so much. This is like an unheard of hour to start Protocol Labs conference. Like genuinely unheard of. I've never seen anything starting before 10. But we have so much content to get through. Thanks for coming out and listening to me. I'm the least interesting person of the day. So actually, I'm not the least interesting person. The least interesting person is me the second time. But I promise. I will do my best to make it rewarding to come out so early. So today I'm going to talk about a lot of the subject that we're here to talk about today. Compute over data is a really transformative thing. In my opinion, there are plenty of things that came before it, but and I know speakers tend to do this when they get up here and talk about new efforts, but it really feels like we are at the advent of something transformative for everyone. And one of the reasons that we're at this, here we are. One of the reasons we're here is because the growth of data is absurd. You can see here a quick look at what it looks like every second on the web. The amount of Instagram and messages, videos streamed, and so on is just going up, and going up extremely fast. There's a projection that we're going to be at 175 zettabytes by 2025. Just an obscene number. It's hard to even fathom. And I guess I just have to turn around. And you may say to yourself, well, I don't have a big data problem. And that may be true for now. But I was going through this and I was trying to figure out and rationalize exactly what it takes to have a big data problem. And so, for example, if you wanted to generate for yourself 100 terabytes in 100 100 days, you could do it with any of these things. 100 or 1,000 nodes generating a gigabyte of logs a day, 100 VMs with 10 services each one's only generating 100 megabytes, that's not that big per day, 20,000 users times 5 videos times 5 minutes long, a fleet of 10,000 vehicles. The average vehicle today has about 70 sensors, and they may be generating 150 megabits a day. Or IoT devices, right? Think about how many IoT devices. That's going up just as fast, maybe faster, than that data thing. And if each one of them only generate a megabyte a day, that is that is 100 terabytes in 100 days. And it's just such a huge number. And the reason I pick 100 terabytes is the amount of time it takes to move 100 terabytes over 10 gigabit per second connection, a very fast connection with no instability, is 1 day. That means when you get to a point where you're generating 100 terabytes a day, and I promise you, you're going to record this, and in 5 years, 100 terabytes is going to sound like 640K, right? Every day, you will be generating 100 terabytes so fast that if you have any delay in processing that after moving, you're going to start falling behind. And that's why compute over data is so important. And I haven't even gotten to the cost, right? A lot of people are like, well, I'm just going to throw, 1,000 hard drives in a cage and call it. But the truth is that that's not free either. Sure, hard drives are cheap, but then the systems, the racks, the ability to wire it together, let alone the administration and maintenance, over 5 years, that's $1.3 million. It's not cheap to be able to do that. So I would argue that compute over data isn't just recommended, it's the law of physics, but law nonetheless. Now today you have a lot of options for doing things like compute over data, and they're great. I don't want to take anything away from this, but they definitely are targeted at a different use case. The use case that they're targeted at is the idea that you're going to have a central, very efficient processing cluster, and you're going to continually stream or move your data into that processing cluster in order to work it. Which is fine, but it's not where we are today when it comes to this greatly distributed set of data generation. And the truth is, I like to joke about this, but the truth is data scientists don't really want that either. They are great, but if you take the standard housing prices example, this is the hello world for data scientists. Looks like this: a few lines of code to group and sort and your data. If you want to do it in Hadoop, it looks like this in Java, right? Not Python. And this isn't even all of it, right? This isn't even all of it, right? We haven't even talked about setup. We haven't even talked about your DevOps cluster, all that kind of stuff. It's a lot, and especially a lot if you're just trying to process these very large things. And these things are everywhere, right? You go out to any hyperscale cloud, and they're going to have an entire open data registry. This is not just, whatever, Caltech or someone like that who's, maintaining these things. It's average people who want to make these decisions on this very large amount of data. So then you say, okay, well, does it have to be decentralized? It's a fair point. But if you look at the definition of decentralized, I was doing this the other day too, it's kind of funny. Organizations whose activities are not performed in one central place, but happen in many different places. I would argue that data, if you look at all those things, many machines, many devices, many users, all of them decentralized. No one lives in a data center. Well, I mean, I do, but most people do not live in a data center. So I would argue that the data is already decentralized, and all that matters is moving the compute to where the data is in order to take advantage of that. To take you through this, if you haven't gone through these kind of exercises, it's really fascinating. If you think about this in just a pure cluster format, you have all these nodes. Here I've drawn it out as 3 different clusters, each node pushing their data to a local store, which is very, very standard. And your data scientist says to that central cluster, okay, I'd like to go and run this processing job. And the data cluster says, okay, time to go. The first thing they have to do is move all that data over, run that processing job. And then finally she says, okay, finally I can start. So she begins that later when it's finally all streamed in. And then she gets the answer and she says, oh no, I've made a mistake, which happens all the time. I'd like to start over. Or excuse me, I'd like to go again. Whatever. There we go, zap. And it's true, that is the case. Again, you're like, okay, well maybe I'll just stream constantly to this very expensive cluster, or maybe I'll move it. But then you're saturating your pipes, you're taking up precious space in this very expensive, very useful cluster. And that's not ideal either. She's blocking out, the next data scientist who wants to come along. So you say, well, aren't things better on hyperscale cloud? Sort of. They are, and they're, highly efficient, and they're more decentralized, but they're not where your data is. They're not in the car. They're not on the IoT device. They're not in your, home on the laptops and things like that. You're still going to need to get it in. And by the way, you're now going to pay ingress and egress costs every time you move stuff around. So that's hugely expensive too. Now the funny part is, again, you look at the costs of doing this. If you go and look at the cloud vendors and what that looks like, it's actually more expensive. I was really shocked to see that. And I think they're even understating this. If you go and really do the math, the ingress egress costs of this actually get really, really expensive. Or worse, they saturate your pipes and prevent your machines from doing other things. Again, neither is ideal. Now, I talked about this just as storage here. I actually am giving them a break, because if you actually go and look at what it costs to run processing over that data, it quadruples, right? You spin up an EMR, a Hadoop cluster, or other big data cluster, and oftentimes the disk is far more expensive. Oops. There you are. Okay. So what we need to do is map to a system that how we collect and store data today. Again, we're not inventing anything new about collecting this data, generating this data. It's already out there. And all it is up to us is map the way we do this processing into this new world. The way I think about it is it comes down to 3 big vectors. The first is local data reproducible execution. That makes sense. You want to have some code or some execution or something that you're able to push to where it is and know that you're doing it in a reproducible way. The worst thing in the world would be to continually push and realize it's not idempotent and rerun the same job over and over again. You want to be able to be smart enough to know that you've already run this processing job at the edge, not in some central orchestrated layer. Second, you really do need to think about a new incentive model, right? Again, a lot of these commercial opportunities and commercial executions are about charging for the centralized compute and the centralized storage of that data. And we're really going to need to change that, right? If I already own 1 million IoT devices and each one of those have, an x86 processor on it, it seems silly that I'd be charging you or I'd be paying you to store the data, it's already there, or run the data. I already have a x86. Why would I charge? We need to have a new model to support that. And I want to be clear, like, we're not saying the existing platforms are out of date by any stretch. It's just they serve a different function. When I've done the initial processing job, filtering, transformation, whatever it might be, compression, that's when these things should take over. Not when they're just, unzipping files or, downscaling your images or whatever it might be. And the third, and is critically important and really undelivered by the marketplace today, is have it be provably secure and verifiable. How can we have a system where there's no open buckets? How can we have a system where I can actually verify at the edge, at that point of computation, that the job was executed on correctly, and go back and reproduce it if necessary? Have the code be visible, have everything be tied together with lineage and rich understanding of exactly what was executed. That's what I'm looking for when we have compute over data. So what we are building, and by we, I mean the entire compute over data community summit, and why we're here to talk about this today, looks like this. First, I need to be able to declare my execution and really a pipeline format, right? So don't think about these as single executions, but think about them as a series of executions that might occur on the edge. So we need a way to reproduce the job packaging and reproduce the pipeline packaging that we can deploy anywhere, basically to anything that can run, x86, ARM, whatever it might be, the same places you can execute binaries today. Second, we need to create a way to orchestrate and decentralize that orchestration, or execution, excuse me. So you take that execution, I say, okay, this is the job. I want to run on all these myriad devices. Go out and do it. When device number 741,620 fails, I want you to watch that one. I want you to restart it. When 910,000 gives me back a non-verifiable answer, I want you to go rerun that or knock that node off the network because it's it's been compromised, so on and so forth. The system has to take care of that itself. And third, once it's done, we need to ensure consistency and we need to ensure verifiability. Taking those things that we were talking about earlier, that as you go and potentially duplicate effort, or do redundant, executions to ensure you're doing it properly, the system should be able to pick that up and run it for you. So that's what I want out of a compute over data network. Now, what does that look like? So we go back to our data scientist. She said she's like one data processing job. The compute over data network, don't think of this as a central cluster. She submits it to the network. And the network says, here's the job. It's got a content addressed ID. It's in 3 chunks. Great. Take it if you can. So node 1 says, I got it. I have this chunk. I'm going to go. Node 2 says, I have that chunk too. Node 3 says, well, I have the chunk, but I'm out of CPU, so I can't do it right now. And node 4 says, well, I have CPU, but I don't have the chunk. So the two figure out how to deal with that. They move the chunk from one place to another, and then they run the processing. And then when they're done, they get it all together. They say, all right, we're done. We're ready to give it back to you. But then the network itself says, hey, you know what? That's great. I'm glad you have answers. I'm going to check to make sure that you all did it right. So I need to re-execute it if necessary. After that, the node says, here it is. Here's the verified. Here's the cryptographic proof. Off you go. And the data scientist says, awesome, I'm ready to go. And only then does she download it, and not from a single source, but in fact from those original things that worked on it. Again, signed, verified, ready to go. So while there certainly is some movement of data, we should always expect things to move around as nodes come up and down and things fall over. A resilient network will always support that. We didn't have a situation where everything needed to be aggregated and all data needed to be moved. And most importantly, we didn't have a central point of failure here. The data scientist, she was able to submit it to the network, and the network was able to take care of it from there. So, in my opinion, I think this pays off across many vectors. I think you have certainly easier to manage. As I said, the network picked up everything. There was no central authority having to deal with, downtime, API upgrades, whatever it might be. It was self-organizing. Each node said what they were going to do as part of this overall flow. It was compatible with existing tools. You want things that run, your average binary, Python, Docker containers, WASM, whatever it might be, anything that can run on these things should be allowed to run on these things. And it's got built-in verification. In the middle, cost-effectively, it's serverless-ish. Nothing is serverless, but this is as close as you get. You have efficient bin packing. The things that have resources are able to shift between them. You're able to move jobs as necessary. Greatly reduced ingress-egress. Again, can't promise we're ever going to get it to zero. It's impossible to get it to zero because you are going to have to move the data around. But the extent to which you can target just the things you need is incredibly important about moving things around, and certainly saves time as well. And finally, reproducible and collaborative. Content addressable. Everything is content addressable. Everything is written to a place, a permanent place, on Filecoin, on IPFS, anything else you'd like. But content addressability is key. We don't want to have the network having to reproduce work that has already been done, and we want this to be valuable forever. We want the content to speak for itself. We don't want a central authority saying, oh, I have an index of all the content that's out there. I'll tell you where it is. Second, what you saw here, a network must have automated metadata and lineage. The number of times I will see people with terrible behavior around this, I get it. They need to get job done, but they'll throw something, they'll export it from a table at one point, they'll drop it as a CSV into an S3 bucket, they'll run a job on it, and they'll produce a model, and presto, you're done. Where did that CSV come from? What was the PII? When that person leaves the company, where did it, what happened there? Because this is content addressable, you get lineage for free. You get metadata for free. It's all part of it. And finally, like I said, communal funding models. Now, so you could certainly have someone take over and say, well, I'm going to pay for this all. But you could also have a collaboration of people do this. Networks like this are far more built in to support that kind of flexibility instead of having a central point that makes all the decisions for you. Now, like I said, it's we who are building it. I will never say that we are the ones who, I know what the right answer here. We already have a Computer over Data working group. We highly encourage you to come and join us. 15 current member companies. We are working on standards. We're working on all sorts of things. And again, for us, we want to establish what the standards, the norms, the expectations of data scientists and end users are going to be so that we can work on the things that make sense together, but then focus on the things that make sense for each of our particular end users. And you might say, which one is the right one-to-one? But there isn't one, right? It's up to you for your use case. You may have seen this. We're tentatively calling it Juan's Triangle. He came up with this. And it's the idea that you can have these various vectors that you will measure your compute over data networks or your particular needs. How much privacy do you need? How much verifiability do you need? And how much performance do you need? And unfortunately, like anything else, you really only get to pick two if you want it like anything. But you can work along a spectrum. You can't sit dead center, don't get me wrong, but you will sacrifice some performance, you will sacrifice some privacy, you will sacrifice some verifiability. If you're in, for example, HIPAA, you may say, you know what, privacy has to be off the scale, everything else doesn't matter, and you can make that decision. But the options really do start from there. And when you think about, so those are really the infrastructure layer. When you go one level up, when you think about businesses that are being built around this, you think about other things that you might be able to tweak around your business as well. So you can think of incentives. Maybe I take a credit card. Maybe I take cryptography or cryptocurrency. Crypto means cryptography, to be clear. Cryptocurrency is a different thing. Collaborations, organizations joining together, that might be an incentive model. You can certainly think of a social good one where, again, we're not thinking of anything new here. SETI at home, folding at home. These were all collaborative things that people joined together to execute compute for the good of humanity. Segmentation. You can have a breadth focused where you're just looking at that very thin top layer that trying to touch every Python developer in the world. Maybe you're depth focused. We're going to understand exactly what's required for PCI compliance, and we're going to understand that end to end and be able to deliver that as a company. Regulated industries, extending that even further. If you have to produce audits and reports that the SEC has to read, that's an entirely different vector as well. And then finally, requirements. Beyond just privacy verifiability, maybe you have a locality or a security requirement. and you could deliver that to an end user. You could certainly think of different hardware types. Every workload is not the same, obviously. If you have video processing, perhaps you have a particular accelerator that is unique in the industry, and you can deliver that. Or green. Again, I've heard many customers seeking out green. Today, it's actually quite hard. Even at the hyperscale cloud level, I have to pick a zone, but like what is in that zone and what happens. Imagine me being able to dial up and down exactly how green it is willing to be, and me targeting only workloads, only vendors who deliver that with auditability. So, you might think this is a lot to think about, and you're not wrong. It is a lot to think about. Would you like to learn a whole bunch more? I have great news for you. So this is what it looks like over the next day. Our schedule looks like this. So on the left-hand side there, and again, you can just pop up with the QR code. I know this is a bit of an eye chart, but on the left-hand side there, you have all of our talks over the course of the day. It's all gonna be in this room, and we're gonna go one at a time through all the various people. Each one of those speakers is going to talk about what they see in the world and hopefully pass on what they've learned. Everything you see there on the left is already doing compute over data in some kind. And it was like crazy to think about how many of those people there were. And we couldn't even fit them all in today, which leads me to the second day. So on the second day, you see 2 tracks. That's much more of an unconference style format. I would love, over the course of today, to figure out what we would like to talk about as a community. Now, I have a bunch of prompts here, and we do have some talks for some folks who are very excited to pass on their knowledge that we felt like were good, appropriate things. But the current working theory is on the left-hand side, or excuse me, right there in the middle, you have what we're calling the platform track. These are people who are building platforms for other people to build on, with concepts around those kind of things. And on the right-hand column, you will see what we're calling the data track, which is people taking the compute over data and doing interesting things. And again, I can't stress enough, this was just early thinking from the compute over data working group. We would love to tweak it if there are particular things. If you would like to talk at one of these, we would like to give you the space to go there. You can throw up slides and things like that. We'll let each group decide what they'd like to be. Now, I want to be very, very clear. It is not here. Do not come back here. I will not be here. Maybe you do want to come back here because I won't be here. But regardless, it will be at the Hyatt Regency. Everyone? Hyatt Regency, not Time Out Market. Just want to be incredibly clear. Okay. And with that, that's me. I have just a couple of minutes for questions, or we can go right into more important talks. Anyone have any thoughts?
Hi, I'm Greg. I'm with Picnic. I'm a mechanical engineer, and so bear with me on this.
No worries.
Right? So you had a slide that kind of outlined like 3 value props for this. And usually, right, you don't get better, faster, and cheaper.
Yeah.
So which one do we not get now, and when might it come?
Well, I'm happy to answer that. Which one? Because I did a couple.
Yeah, it was later than that. Keep going. Sorry.
Got it.
Yeah, essentially, right, you have easier, so faster, yeah.
So you're right. You don't get all 3 to deliver. Well, I will take that back. On this one, I think this is the price of entry. I do not think you will be a successful compute over data network if you don't deliver against all 3 of these. If you are not easier to manage than existing compute over data solutions today, you're dead. If you are not more cost effective, why would they ever change? Unless it was dramatically easier to manage. And if it's not reproducible and collaborative, it will be I don't know, it's like doing computation and having no idea what the answer is. Like there's just no way this is the price of entry.